Hello my dear friends, I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are learning your second chapter, chemical bonding of ICSE chemistry, and in this video, we are going to learn all the concepts of covalent bonding, okay? And in the previous video, we have learned all the concepts of ionic bonding. If you have missed that video, please do watch because you won't understand how to draw the electron dot structures, okay, of covalent compounds, covalent molecules if you haven't watched that video, because in that video, I have taught you the basics of electron dot structure, okay? So, without wasting much time, let's start and let's rock. Okay, so I know that you have studied the covalent bonding as well in your 9th grade, right? Previous grade, the basic definition and the orbit structure diagrams of some covalent molecules. Okay, so we are going to just quickly run through, we are quickly going to revise these basic terms of covalent bonding, that is covalent bond, covalent compound and covalent molecule, okay? But pay attention to these basic terms because these are very much important as well, okay? So first is covalent bond. Covalent bond is a chemical bond. Now we know it is a type of chemical bond, right? So it is a chemical bond which is formed by mutual sharing, okay, of one or more pairs of electrons between two combining atoms, okay? Now let's understand this thing, okay? So I have drawn the orbit structures of covalent, some covalent compounds and covalent molecules to show you, to make you understand what is actually the covalent bond, okay? Why I have drawn the orbit structures? Because you have already learned those, okay? So you would understand those pretty well, okay? So this is HCl, okay? This is its orbit structure diagram. So you can clearly see here the shared pair of electron, a shared pair, okay, one shared pair of electron, okay, between hydrogen and chlorine, okay? Now the chemical bond which is formed by mutual sharing. What does this mutual sharing means? Okay, very important term. See here, the shared pair of electron has two electrons. Out of this, one is contributed by hydrogen, this X wala, okay, and this circle electron, okay, it is contributed by chlorine, okay? So I'm just trying to represent it with the symbols, okay, so you would understand. Now this is what actually the mutual sharing means. One electron of the pair is contributed by one atom, another electron of the pair is contributed by another atom. So mutual sharing of one or more shared pair of electrons. So you can see here in this oxygen molecule there are two shared pair of electrons. In this nitrogen molecule there are three shared pairs of electrons, okay? So the chemical bond formed by mutual sharing, okay, of one or more shared pair of electrons between two combining atoms is called as a covalent bond, okay? Very simple. Now what is covalent compound? Exactly, the definition would be almost same, okay, same thing we would see, but covalent compound is actually a chemical compound, right? So it is a chemical compound. Now when the word compound means, you have to just keep this in mind that this compound is formed, okay, or the compound is actually formed from two or more atoms, okay, of different elements, right? So the molecule of a compound, okay, is made up of two or more atoms of different elements. Now let's move on again to the definition. So chemical compound formed by mutual sharing of one or more pairs of electrons, the same term, okay, mutual sharing of one or more pairs of electrons between the combining atoms, okay, these are the combining atoms, is called a covalent compound. Now very clearly you can now pay very much attention, because see, covalent compound in this case is just the HCl, okay? O2 and N2 is not a covalent compound, because yes, what I have told you, why I have told you this thing, just to understand, just to make you understand this thing. See, two or more atoms of different elements. Here there are two atoms but of same element, two atoms of same element. So these are actually the covalent molecules, okay? These are not the covalent compounds. So please don't mix it up, okay? This is a covalent compound, HCl, because the two atoms are of different elements, and such a compound is formed by mutual sharing of one or more pairs of electrons between the combining atoms. And what is a covalent molecule? It is simply the molecule which is formed by, the molecule which is formed by mutual sharing of one or more electrons, one or more pairs of electrons, okay, between the combining atoms is called as a covalent molecule, okay. Now moving ahead, let's see the conditions for the formation of covalent bond, okay. So like the same way we have seen the conditions for the formation of ionic bond, here are the conditions for the formation of covalent bond. So we are going to just correlate or understand the conditions in the same way as that we have done for the formation, as that we have done for understanding the conditions for the formation of ionic bond, right? So what we are going to do, I'm going to take a simple example of a molecule, okay, which is having a covalent bond. So suppose I'm taking Cl2, okay, it's my favorite chlorine gas, but it's very dangerous, right? Now this chlorine molecule is made from two chlorine atoms, very simple, and each chlorine atom is having 7 electrons in its outermost shell, okay. So this is the electron dot structure of each chlorine atom, okay. I have drawn it separately. Now why I have drawn this thing? See, both the chlorine atoms have 7 electrons. They are in desperate need of 1 electron, correct? So both of them want 1 electron, but both of them are not at all willing to give up a single electron, right? Because they want one more electron, yeah, they won't give up the single electron, right? To each other. Now the condition here is they have very low tendency to lose electron, right? To put into the scientific terms, and in contrast to this thing, they have very high tendency to gain up the electron. Like both of them are like desperate for the electron, 1 electron just. So high, okay, tendency to gain the electron. Now you only think, you and your very much best friend, okay. Now both of you want a single chocolate. Now the chocolate is in front of you, both of you want that. Now what you would do? You want your best friend to be happy, right? You want yourself also to be happy. So now you cannot be happy by giving the chocolate to your best friend, okay. You are very small, don't think about you yourself as a big person. You are very small, you would cry if you would give the chocolate to your best friend. Now your best friend would become happy, but you would become unhappy. Same way, vice versa, in case of your best friend also. So what both of you would do? You would share that chocolate, right? So that would make both of you happy. Same thing is done by these two atoms, okay, two chlorine atoms. They share their electron, and we know how they share the electron. We have studied it in the orbit structure diagram, okay. Now that's not the point. They share the electron, right? So here, first of all, the tendency to lose the electron is very less, very less, and the tendency to gain the electron, in contrast, is very much high. Now let's correlate these two tendencies with ionization energy and electron affinity. Okay, this is our main point. So let's correlate the low tendency to lose the electron with ionization energy. So try to recollect what we have studied about ionization energy. When the tendency to lose the electron is less, ionization is very high. Correct? Okay. Why it is very high? You can go back and see that video. You would be able to understand it. Okay. I have explained it in very much detail. So low tendency to lose the electron means very much high ionization energy. And yes, so this means that since both of the atoms have low tendency to lose the electron, they have very much high ionization energies. Okay, so this is our first condition. Now, since both of the atoms have very high tendency to gain the electron, we will just correlate this tendency to gain the electron with electron affinity. Okay, so we have studied in the previous chapter that when the tendency to gain the electron is very high, okay, so electron affinity is also very high. So both of the atoms have high electron affinities as well. So for formation of covalent bond, okay, the both of the atoms should have high electron affinity. Okay. Now high electron affinity means more negative value, okay, of electron affinity. Now we know that what they do, they share the electrons, right? So here the transfer of electron is like nearly impossible. They are not at all willing to give up the electron. So if they are not at all willing to give up the electron, so electron cannot be transferred from one atom to another atom, correct? Now this highly impossible transfer of electron, what does it mean to us? Okay, we are going to correlate this with the difference in the electronegativity. Okay, let's make it simple. So the difference in the electronegativity between the combining atoms must be 0 or negligible. Now how we are going to correlate this? With the absolutely zero tendency or very small tendency of transfer of electrons, okay, between the atoms. See, in ionic compounds we have seen that the electronegativity difference between the combining atoms should be large, right? And at that time I have told you that this concept has some detailed explanation, but you would learn it in the higher grades, okay? But for now, what I have told you to remember, in case of ionic compounds, when the electronegativity difference is large, it actually, what it does, actually it is supporting the electron transfer. The electron transfer is easier, right? And now in this case we know that electron transfer is highly impossible, okay? So if it is highly impossible, right, or it is highly not feasible, okay, then this means that the electronegativity difference should be like 0, right? There should not be any electronegativity difference at all, okay? Or if there is an electronegativity difference, it should be very much close to 0. Now very much close to 0, then we can ignore it, and such values are called as negligible values, okay? So that's why, see, the electronegativity difference should be 0 or negligible. Now you would have understood this thing, okay? Now let's move ahead. Now let's correlate these two properties or these two conditions which should be possessed, okay, which should be in the combining atoms, okay, with electronegativity. Now what do you think? An atom is which is having high ionization energy and more negative value of electron affinity or high electron affinity, which atom it would be? Either it would be an atom of metal or atom of non-metal, okay? So we already know non-metals have very high ionization energies. Yes, this thing also we have studied in the first chapter. And non-metals also have very high electron affinity or more negative value of electron affinity, right? So both the combining atoms should be the atoms of non-metals, right? And we also know that non-metals have very high electronegativity, right? So from here comes the condition. Since both the atoms are non-metals, right? Both the combining atoms are non-metals, and we know non-metals are having high electronegativity. So we are saying that both the combining atoms should have high electronegativity, okay? And just now we have learned that yes, both the combining atoms are of non-metals. So the covalent bond which would be formed due to the mutual sharing of one or more pairs of electrons, it would be formed between the atoms of non-metals, right? Now these atoms of non-metals can be same, just like in this case you have studied H2, Cl2, N2, O2. You have studied the orbit structures of this covalent molecules, okay? Or the covalent bond can be between the atoms of different non-metals, okay? Just like this, HCl, NH3. Now let's see the types of covalent bond and a concept of covalency, okay? So first, covalent bond is divided into 3 types, very simple types: single covalent bond, double covalent bond, triple covalent bond, okay? Now what does this mean? Single covalent bond, what does it mean? It means that the combining atoms, okay, are having one shared pair of electrons, okay, and these combining atoms are mutually sharing the pair of electron. See, in this way, okay, and we denote this bond, okay, by a single line. Very simple. So which molecules, or let's see the examples, okay, so it would be clear to you, like this: H2, okay, Cl2, okay, and you can also have HCl, okay. So these molecules are having single covalent bond. Why? Because in between the combining atoms only one shared pair of electron is mutually shared, okay. Same goes with the double covalent bond. Here two shared pairs of electrons are mutually shared, okay, and we represent it with the help of 2 lines. So examples are like, see, oxygen molecule, okay. Here we know that 2 shared pairs of electrons are mutually shared between the two oxygen atoms. We have already studied in orbit structure diagrams, right? And we can also have this example as of carbon dioxide. See here, in this case, carbon and between oxygen, okay, there are two shared pairs of electrons. Here also, between carbon and oxygen, there are two shared pairs of electrons, okay. And triple covalent bond. So same way, three shared pairs of electrons, okay, are mutually shared. Mutually shared, I have already told you, which means that the in a shared pair of electron, one electron would be contributed by one atom, another electron is contributed by another atom. Same goes with this one. This electron is contributed by one atom, this electron is by another atom, this electron is by one atom, this electron is by another atom. So this is called mutual sharing. I have already told you, right? Now we would represent it with the help of three lines. Triple covalent bond. Okay. Now which molecules have this triple covalent bond? Like this, nitrogen. Okay. Now why I am not in detail telling you, because you have already learned its orbit structure, and if you won't remember, if you are not able to remember, don't worry, we are going to see the electron dot structures. So in the electron dot structures, it would be very clear to you that how these are having one shared pair of electron, two shared pair of electrons, three shared pair of electrons. Okay, chalo. Now moving ahead to covalency. So it is very small concept, very interesting concept. See, what is covalency of an atom? It's just like the electrovalency, okay, but not exactly like electrovalency. Covalency of an atom is the number of the electrons of that atom, okay, number of its electrons, which are taking part in the formation of shared pairs, okay. Now, let's try to find out, let's try to apply this concept, okay. So, I want to find out the covalency of, suppose, oxygen, okay, in this O2 molecule. So how would I find out? So I know that oxygen has two shared pairs of electrons, okay. So two oxygen atoms have two shared pairs of electrons. Now what is covalency? I have to find out the covalency of this oxygen atom. So covalency is actually the number of its electrons. So number of the electrons of this oxygen taking part in the formation of shared pairs, okay. So here I can like this also show you, okay, this is the shared pair. Now how many electrons of oxygen are taking part in the formation of these shared pairs? Okay, this is one shared pair, this is another shared pair. So this electron and this electron of this oxygen atom is taking part in the formation of shared pair, right? So this means that oxygen's covalency is 2. Okay, similarly you can find out the covalency in case of hydrogen here, in case of H2 molecule. Okay, what it would be? See here, one shared pair of electrons, one electron of hydrogen is taking part in the formation of shared pair. So covalency of hydrogen is 1. Similarly, covalency of chlorine is also 1. Okay, see here, one shared pair of electrons. So this one electron of this chlorine atom is taking part in the formation of shared pair. Okay, and in this way, see nitrogens, you try to find out the covalency of nitrogen. Pause the video here, try to find out the covalency, and then again unpause it. Okay, so here see 3 shared pairs of electrons. Okay, now 3 shared pairs of electrons means this electron, and this electron of nitrogen. Okay, these are taking part in the formation of shared pairs. Okay, so this nitrogen's covalency is 3. Similarly, this nitrogen's covalency also would be 3, right? 1, 2, 3. 3 electrons taking part in the formation of shared pairs. Here also 1, 1. Okay, same way. This oxygen is also 2. Okay. Now let's see the another types of covalent bond. Okay, so covalent bond are also divided into 2 types, okay, in some different way. So these 2 types are non-polar covalent bonds, okay, and polar covalent bonds. Now this type is also very much important. Okay, now what does this mean? Non-polar covalent bond, what does this mean? In this covalent bond, okay, the electrons are shared equally between the combining atoms. Okay, now what does this mean? Let's take an example to understand this thing. Okay, so I am taking an example of hydrogen molecule, okay, H2 molecule. Now here the electron pair, okay, this electron pair is shared between the 2 hydrogen atoms, right? Now this electron pair is shared equally between the 2 hydrogen atoms. Now what does this mean? Shared equally means the distance of the shared pair, okay, from this hydrogen atom and the distance of the shared pair from this hydrogen atom, okay, is exactly the same. So that this means that the electrons which are shared, they are shared equally between the combining atoms. Okay, and such bonds, okay, such bonds are called as non-polar covalent bonds. Okay, now why is it happening? Let me give an interesting example to you. See, you and your friend, okay, you and your best friend, you both have the same power. Okay, now you have been given a rope, and at the center of the rope there is tied you have tied a small handkerchief, okay, red handkerchief. Now you and your friend are pulling that rope, but since you have same power, you would be pulling the rope with the same power, so that the handkerchief in the middle of the rope wouldn't move either on that side or either on your side. So what would happen? The distance of that handkerchief from you and the distance of that handkerchief from your friend would be exactly the same, right? That's what is happening with this H2 molecule. Both the hydrogen atoms are pulling this shared pair of electron with the same power, with the same extent. So that's why this shared pair of electron is like lying in between, in middle of both the atoms. Okay. Now, since they are pulling that shared pair of electron with the same extent, okay, what does this mean? Can we relate this with electronegativity? Right, we have studied in the first chapter, electronegativity is actually the tendency of the atom, okay, to attract the shared pair of electrons towards itself. Now, since both of them are pulling the shared pair of electrons with the same extent, so they are having absolutely same tendency, right, to pull the electrons towards themselves, okay, to attract the shared pair of electrons towards themselves. And yes, this means that they would have same electronegativity, correct? Now, why is this happening? This is because of the same electronegativity, and it's very simple. You can see here, these atoms are of same element, so it's obvious that the combining atoms would have same electronegativity, right? Now, let's move ahead, okay, towards the polar covalent bond. Now, what is happening? Ulta, you would have guessed it, right? Okay, in this polar covalent bond, the electrons, okay, are not shared equally between the combining atoms. Okay, let's take an example. See here, between hydrogen and chlorine, okay, the electron pair which is shared, it is like more towards the chlorine. Okay, now since it is more towards the chlorine, see, the distance between the electron pair and the chlorine is less, distance between the electron pair and the hydrogen is more, right? So that's why we are saying that the electrons are not shared equally, correct? Since their distances from the shared pairs are not equal, the electron pairs are like more towards the chlorine. Okay, now this thing, why is this happening? The exactly opposite reason of the in case of non-polar covalent bond. See here, hydrogen and chlorine. Okay, hydrogen has electronegativity 2.2, chlorine has electronegativity 3.0. So this means that chlorine has a higher tendency to attract the shared pair of electrons, and that's the reason chlorine is attracting the shared pair of electrons more towards itself. Since it is attracting the shared pair of electrons more towards itself, the shared pair of electrons have been shifted towards the chlorine. Very simple. Okay, now see, the electronegativity difference is not too much, it is slight difference in the electronegativity, but because of this slight electronegativity difference too, the shared pair of electrons are being shifted. Okay, so what's the reason? Reason is very simple, slight difference in the electronegativity between the two combining atoms. That's why the shared electrons are not being shared equally. Okay, the shared electrons are being closer towards a particular atom, okay, out of the molecule. Now let's build this concept ahead, okay, further. So since the electrons are more closer towards the chlorine, so the negative charge around the chlorine is like slightly more. Okay, so this chlorine starts to develop slight negative charge. Okay, so slight I have represented with delta, negative charge. And now since the electrons are like slightly away from the hydrogen atom, so it would now be developing slight positive charge, right? Here there is slight negative charge, here it is slight positive charge. Okay, now see here, in this molecule HCl, there is slight negative as well as positive charge, and such molecules which are having slight negative and slight positive charges, okay, are called as dipole molecules. Okay, so this is the concept, okay, which we are talking about further. Okay, further after understanding the polar covalent bonds. Now, how to represent such dipole molecules? Very easy representation they have. Okay, so here suppose there is HCl, right? We are showing it with single covalent bond because there is only one shared pair of electrons between them, but we have to show that that shared pair of electron is shifted towards the chlorine atom. So just what we would do, we would just show an arrow here. Okay, arrow pointing towards chlorine. So this means that yes, this is a polar covalent bond and the electron, the shared pair of electron is shifted towards the chlorine atom. Okay, very clear. Now, from this you can just clearly make out that since the polar covalent bond is formed due to the unequal sharing of electrons between the combining atoms, right? So why is it so? Because of the slight difference in the electronegativity. Now this means that the atoms, okay, the combining atoms should be different, right? If the combining atoms are same, okay, same, then the electronegativity difference would not be slight, okay, the electronegativity difference would be 0, correct? Same electronegativity they would have. Now since there is a slight difference in the electronegativity, this means that these polar covalent bonds are formed between the atoms of different elements. Okay, just like you have seen here, HCl, okay, different elements. Now there comes the exception. Okay, now this exception has a logical reason. Okay, don't worry about this, that why is it behaving so, I will tell you. Now here exception, what it states, that carbon hydrogen bond in methane, this carbon hydrogen bond is non-polar covalent bond. Okay, now why is this so? See, this is formed between the atoms of different elements. It should actually be polar, right? But it is non-polar because here the carbon and hydrogen, see, carbon is having 2.5 electronegativity, hydrogen is having 2.2 electronegativity. Okay, what you have to remember is, see, they are having the electronegativity difference, okay, which is very small, very slight, very little, not slight, actually it is very little, 0.3. And due to this very little electronegativity difference, okay, they are not forming the partial positive charges and partial negative charges, okay, or slight positive charges and slight negative charges. Since they are not forming these charges, the electron pair, okay, which is between this carbon and hydrogen, it is equally shared, okay, because electron pair is neither more towards carbon nor more towards hydrogen, correct? Since it is equally shared, so we can say that this covalent bond is non-polar covalent bond. Very simple. So friends, now let's see the types of covalent compounds. Okay, so there are two types of covalent compounds: non-polar covalent compounds and polar covalent compounds. Now, since we have studied the basics, now it would be easy for us to understand. See, non-polar covalent compounds, which are those compounds? Okay, so such covalent compounds which are having non-polar covalent bonds are simply non-polar covalent compounds. Now we know what is non-polar covalent bond. Okay, so example is methane, CH4. Just now we have seen the carbon hydrogen bond is non-polar, right? Exceptional case. And because of these non-polar carbon hydrogen bond, see, the methane molecule, okay, is having this structure. Means we can represent methane molecule like this, and the entire molecule, okay, since this bond, carbon hydrogen bond, this carbon hydrogen bond, this carbon hydrogen bond, this carbon hydrogen bond are non-polar, so entire molecule becomes non-polar, okay, and we therefore call this as a non-polar covalent compound, okay, or non-polar covalent molecule as well. Now such covalent compounds, okay, which may have polar covalent bond, okay, second thing, okay, so such compounds which have polar covalent bonds, okay, those can also be non-polar covalent compounds if the molecule as a whole is symmetrical, okay. This condition is very important, okay. So such covalent compounds which are having polar covalent bonds, okay, are non-polar covalent compounds if the molecule as a whole is unsymmetrical. Now, what does this mean? Let's try to understand this thing. See with the help of example, CCl4. Now, here carbon, okay, and chlorine bond, okay, in CCl4. CCl4 is carbon tetrachloride, okay. The 4 chlorine atoms are attached to this carbon atom, okay. Now, this carbon chlorine bond is polar. Why it is polar? Because chlorine is having electronegativity 3.0, carbon is having electronegativity 2.5. So, there is a difference of 0.5, and 0.5 difference of electronegativity is considerable, okay. It is slight difference. So, if they are having slight difference, then we know which type of bond it would form. Polar covalent bond. So, yes, this carbon chlorine bond is polar covalent bond, okay. Similarly, this carbon chlorine, this carbon chlorine, this carbon chlorine bond, all are polar covalent bonds. Now, because of this, the entire molecule should be polar covalent compound, but here the role plays which is symmetry, okay, of the molecule. Now we don't have to go into the details, okay, whether how it is symmetrical and all those things. Just remember this thing right now is carbon tetrachloride is having symmetrical is a symmetrical molecule, okay, and since it is a symmetrical molecule, so though it is having polar covalent bonds, it is a non-polar covalent compound, okay. Now, one more thing, H2Cl2 N2O2, okay, these are non-polar covalent molecules, okay. I have already told you that molecules and compounds means how to distinguish between molecules and compounds, okay. It's very basic thing. So these are molecules we all know, and these are non-polar covalent molecules because these molecules are having non-polar covalent bonds, okay. Now, how I could figure it out? Very simple. We have already studied non-polar covalent bonds are formed between the atoms of same element, right? The atoms are same, okay, atoms are of same element and they have same electronegativity. That's why they have same electronegativity, right? So see here, H2Cl2 and 2O2, the covalent bonds are formed between the atoms of same element, hydrogen, chlorine, nitrogen, oxygen. Very clear? Okay, now let's move to the polar covalent compounds, okay. Now these polar covalent compounds have, so the covalent compounds are having polar covalent bonds, okay, and such covalent compounds are polar covalent compounds if the condition is the molecule as a whole is unsymmetrical, because we know that though if the covalent compound is having polar covalent bonds but the molecule as a whole is symmetrical, it becomes non-polar covalent compound, right? So polar covalent compounds are the covalent compounds which are having polar covalent bonds, but the molecule as a whole should be unsymmetrical. Very clear? Now let's see the examples: NH3, HCl and water, okay. So here we can draw the structure, okay. I'm showing you the structures, okay. No need to remember the structures, just for your understanding purpose. So here nitrogen hydrogen bonds are polar bonds, okay, polar covalent bonds. So that's why we know that when the bonds are polar covalent bonds, what would happen? The electron pair is shifted towards the more electronegative atom, right? Like in the case of HCl, we have seen the electron pair was shifted towards chlorine, okay, because it would strongly attract the electrons. The same way nitrogen is strongly attracting the shared pair of electrons, so electron pair is shifted towards nitrogen. So because of this nitrogen hydrogen bond, what would happen? The nitrogen would be developing slight negative charge, hydrogen would develop slight positive charge. Similarly, here also hydrogen would develop slight positive charge, again nitrogen would develop slight negative charge. Same way, slight positive charge, slight negative charge, okay, because of this nitrogen hydrogen bond. So what is happening? 3 slight negative charges are being developed at nitrogen and slight positive charges are being developed at hydrogen, okay. Now next is water, right? So this is the structure of water. Here water develops 2 slight negative charges. Why 2 slight? Because see here hydrogen is developing, here this hydrogen is developing slight positive charge, this hydrogen is developing slight positive charge. So oxygen would develop 2 slight negative charges, so I have directly written it 2 slight negative charge, okay. And then HCl, we already know, slight positive charge, slight negative charge on the chlorine, okay, in this way. Now don't try to figure it out from the structures that whether these molecules are symmetrical or unsymmetrical, okay. I have also told you in case of CCl4 as well, you just remember it that this CCl4 is symmetrical, okay, because the concept which is required to explain this is belonging to the dipole moment and all those things which you would study in your higher grades, okay. So for now you have to remember that CCl4 molecule as a whole is unsymmetrical, sorry, it is symmetrical, okay. So and here NH3, water and HCl, these molecules as a whole are unsymmetrical, okay. Now, since these molecules as a whole are unsymmetrical and they have polar covalent bonds, okay, so they are polar covalent compounds. Very simple. So, till this point, we have studied the basics of covalent bonding and some important concepts of covalent bonding as well, okay. Now, we are moving towards the crux of this chapter, the electron dot structures of covalent molecules and covalent compounds, okay. So, first we are going to see the electron dot structures of non-polar covalent molecules, okay. I am making it simpler for you to study, okay. I'm not mixing the covalent molecules and compounds with each other, okay. Let's separate the covalent molecules, let's separate the covalent molecules and covalent compounds in such a way that you would feel easier to study their electron dot structures, okay. So, H2, Cl2, N2 and O2, we know they are non-polar covalent molecules. So, let's learn how to draw their electron dot structures. So, very simple, you have to just understand the formation of them, then you can automatically draw the electron dot structure. So, in case of hydrogen, we know I am drawing the individual electron dot structures. Only shell has one electron of hydrogen. So, I have depicted it with the same symbol because I have already told you basics. You directly use the same symbol for representing the electrons of the atoms, okay, in a molecule, and such atoms which are of same element, okay. So, here see the hydrogen atoms are there only. So, I have just used same symbol, okay, for representing their electrons. Now, what is the case here? Both of them wants to attain duplet, which means 2 electrons in its shell, so that they would attain the helium's configuration, right, and they would become stable and happy. So, what they prefer to do, neither of them wants to give up the electron. So, both of them also want 1 electron, so they share the electron, right, the same way you and your best friend would do, share the chocolate. So, they share their electron, and this shared electron is like this, okay. This hydrogen brings its electron here, this hydrogen brings its electron here. So, they share their electron, and this is the electron dot structure, simply, okay. Moving to the Cl2, both the chlorine atoms individual electron dot structure, you already know. You can also try to draw this electron dot structure with me, okay. So, 1, 2, 3, 4, 5, 6, 7, okay, we have already studied 1, 2, 3, 4, 5, 6, 7 because chlorine's outermost shell has 7 electrons, right. So, I have depicted 7 electrons with dots, okay, same symbols. Now, what would happen? Both of them are they are desperately wishing that they would get 1 electron, just 1 electron, and then their life is changed in this way. So, both of them like want to attain the configuration of argon. So, they need 1 electron so that they would have configuration 2, 8, 8, same as that of argon, and they would become happy. Now, what are they doing? Neither of them is willing to give up the electron, and both of them want the electron, so they share the electron, right. So, what these 2 chlorine atoms do? The remaining pairs of electrons, they remain as it is because both of them want just 1 electron, right. So, they share their 1 electron with each other. See here, this chlorine atom's electron, this chlorine atom's electron is here, and again in this way the remaining 3 unpaired electrons are here itself, okay. Very clear? Now, when you are drawing the electron structure for the covalent molecules and compounds, you have to make sure of one thing. After drawing the structure, you can just check one thing. It would help you actually to just figure out that you have drawn the right structure or not, okay, right electron structure or not. So, what is that thing? You just check whether each of the atom has attained octet or not. And in case of hydrogen, it would attain duplet. So, see here, it is attained duplet. See, hydrogen has 2 electrons, okay, in its outermost shell. This hydrogen is also has also 2 electrons in its outermost shell. Why? Because this hydrogen's this electron is its own electron. This hydrogen's this electron is its own electron. But they have since shared their electrons with each other. So, what we say that this hydrogen, okay, here in this way, it is having the 2 electron, okay, with it. So, attained duplet. This hydrogen is also having 2 electron with it. So, it has also attained duplet. This we have learnt in orbit structures, right. So, same way, whether they have attained the octet or not, we have to check in case of all other atoms. So, see chlorine 1, 2, 3, 4, 5, 6, 7, 8, okay. Shared pair, you just count it with them, okay, that particular atom, whatever the number of shared pair is there. So, here also see unshared pairs are there here 1, 2, 3, 4, 5, 6 and shared pair is 7, 8. So, it has also attained the octet. Your structure is correct, okay. So, you can just cross check it. Now, next is N2. Now, you can pause the video here and then try on yourself to draw the structure of N2 and O2. If you can draw, very good, well and good. If you can't, no worries, I will tell you how to draw it. Okay, so here electron dot structures, okay, individual electron dot structures. I'm drawing 1 2 3 4 5 electrons, 1 2 3 4 5 electrons, because nitrogen's electronic configuration is 2 comma 5. Okay, these things you know, right? These are very basic things. So 5 electrons and 5, so 5 electrons I have showed in the outermost shell. Okay, 5 electrons I have showed around the symbol, okay, which are the outermost shell electrons, correct? Now what is happening? This nitrogen and this nitrogen atom, they want to form into, now they are in desperate need of 3 electrons. See, 1 2 3 4 5, it needs 3 more electrons, then it would attain octet, right? It would attain 2 comma 8 and the configuration of neon, and it would become happy. Same is the case with this nitrogen as well. So since they want 3 electrons each, they share 3 electrons with each other. Simple. So 1 2 3 1 2 3. Okay, so this nitrogen atom has shared this its own 3 electrons. So this 1 2 3 has been here. Okay, so remaining 2 are sitting on its head. You think in this way. Okay, these are not taking part. Okay, in this case also 3 electrons have came here. Okay, to form the shared pairs. Remaining 2 sitting on its head. Okay, so this is the electron dot structure of N2. Simple. Now check it. 1 2 3 4 5 6 7 8. Right, I have told you to count the shared pairs as well for that particular atom. So it has attained octet. Same here, 1 2 3 4 5 6 7 8. So it is also attained octet. Clear? Now oxygen's case, same way. Oxygen 1 2 3 4 5 6. Okay, 1 2 3 4 5 6, because we know configuration is 2 comma 6. 6 outermost shell electrons I have represented. Now it is in desperate need of 2 electrons. So each of them is in desperate need of 2 electrons. So they share their 2 electrons with each other. So these 2 electrons oxygen share with this oxygen atom. These 2 electrons this oxygen atom shares with this oxygen atom. So how I would write the electron dot structure? Very simple. I would bring this closer, a slight closer. Okay, so and remaining unshared pair of electrons, I have kept it as it is. Now this is the electron dot structure of oxygen. Check it. 1 2 3 4 5 6 7 8, right? 1 2 3 4 5 6 7 8. Octet is complete. Now moving ahead, we are going to see the electron dot structures of non-polar covalent compounds. Okay, not molecules. So we have 2 non-polar covalent compounds which we have to study. Okay, their electron dot structures CH4 and CCl4. Okay, so how CH4 is formed, let's try to figure it out. You could easily draw the electron dot structure of CH4, methane. So carbon, okay, it has 4 electrons in its outermost shell, right? 2 comma 4. Its electronic configuration, it is in desperate need of 4 electrons more, so that it would attain octet, it would become stable by attaining the electronic configuration of neon, right? So what it does, see, 1 2 3 4 electrons in its outermost shell, I have drawn in this way. Now there are 4 hydrogen atoms. So what these 4 hydrogen atoms are doing, they have 1 electron each, right? So in this way, this hydrogen 1 electron, this hydrogen 1 electron, this hydrogen 1 electron. Now see, I have taken care of one thing. I have depicted, or I have represented the electrons of different atoms with different symbols. Okay, so now let's move ahead. So how carbon would attain the octet? It is having 4 electron, it needs 4 electron, so it would share its 4 electron with 4 electrons with hydrogen atoms. Okay, and hydrogen would share its 1 electron, okay, with carbon atom. Now let's see what is happening. Okay, carbon 1 2 3 4. Okay, then it is sharing its 1 electron with each hydrogen atom. See, I have drawn this. Okay, and hydrogens are in turn what they are doing, they are sharing their 1 electron with carbon atom. Now what has happened? See, here hydrogen, each hydrogen atom, okay, let's check their duplet, whether they have attained duplet. See, hydrogen 1 2, yes, hydrogen 1 2, hydrogen 1 2, hydrogen 1 2, right? X and dot, so they have attained a duplet. Very well. Okay, so hydrogens are stable. And now let's say about the carbon 1 2 3 4 5 6 7 8. They have also, so carbon has also attained the octet. So yes, our objective is complete, and this is the electron dot structure of methane. Okay, Very simple. Now you try to draw the electron dot structure of CCl4. Pause the video here and try on your own. If it gets wrong, no issues. Okay, I'm drawing it here. So again, same way, carbon. Okay, 4 electrons it is having in its outermost shell. It is in desperate need of 4 more electrons. So what it would do? It would share its 1 electron with 4 chlorine atoms. Okay, so see here, 4 chlorine atoms. Okay, and now what chlorine is doing? See, chlorine is in desperate need of 1 electron, right? I'm drawing here the separately the electron structure of chlorine. Chlorine is just in desperate need of 1 electron. If it gets that one, it is happy. So see here, chlorine is getting the 1 electron. Okay, now what it would do? It would bring this electron here. Okay, it became happy, and rest 3 pairs you have to just draw as it is here. 1 2 3 4 5 6. Same way here as well, this chlorine atom. Okay, this electron is coming here. Rest 3 pairs are as it is. Same way, 1 2 3 4 5 6 7. Okay, 1 2 3 4 5 6 7 8. Okay, so see, if you would count, okay, chlorine atoms have attained the octet, and as well carbon atoms have also attained the octet. Okay, you can pause here and you can count very calmly. Okay, so moving ahead, now we have to see just the electron dot structures of these 3 polar covalent compounds, and our job is done. We have learned the electron dot structures of covalent molecules and covalent compounds. Okay, so HCl, H2O and NH3. So here we know HCl. Here I would draw the individual electron dot structures. Hydrogen is having only 1 electron, chlorine is having 7 electrons, right? What it would do? It is in desperate need of 1 more electron. Chlorine is also in desperate need of 1 more electron. They would share their electrons. So how they would share? Here is hydrogen, here is chlorine. Okay, here is the electron of hydrogen which it brings here. Okay, chlorine brings this electron, okay, closer. Okay, and then they share their electrons with each other. Remaining 1 2 3 4 5 6 electrons of chlorine remain as it is. Okay, so this is the electron dot structure of HCl. Now let's check it. Hydrogen's duplet is complete. 1 2. Chlorines 1 2 3 4 5 6 7 8. Octet is complete. Okay, next, moving ahead, water. So what water would do? Oxygen is having 6 electrons, right? 1 2 3 4 5 6 in its outermost shell, and hydrogen, it is having 1 electron, right, in its only shell, we know. So oxygen is in need of 2 electron, we know that. Hydrogen is in need of 1 electron. So what oxygen can do? It can follow this process. Okay, it's 2 electrons, it's 2 pairs, it would keep it as it is. This electron, it would bring it here. Okay, this electron, it would keep it here itself. So here and here. And what hydrogen would do then? Hydrogen is ready to share its 1 electron with oxygen, because it would get 1 more electron from oxygen. Okay, here also it is getting 1 more electron from oxygen. So it is by sharing, it is completing its duplet C, 1 2 1 2. And in case of oxygen C, 1 2 3 4 5 6 7 8. Oxygen is also very happy. So this is the electron dot structure of water, H2O. Okay, now next, NH3. Same way, nitrogen's electron dot structure 1 2 3 4 5. Okay, there are 3 hydrogens. Okay, so here X cross. Okay, means cross. Now nitrogen is in desperate need of 3 electrons so that it would attain the octet. We already know these things because now we have done this thing. Okay, we have understood this thing by drawing the electron dot structures of N2, O2, right? So nitrogen needs 3 electrons to attain the stable inert gas configuration of neon, so it would become happy. So what it would do? It would arrange its electron, it would share its 3 electrons with 3 hydrogen atoms, right? Now, so it is sharing, so the remaining 2 electrons are remaining on the top of it. Same way, it would bring its 3 electrons on the 3 sides in this way. Okay, 1 2 3 1 2 3. Okay, and what hydrogen would do now? Hydrogen is ready to share its electron. Okay, it's always ready. Yes, in this way. So see, hydrogen is attaining duplet 1 2 1 2 1 2, and nitrogen C 1 2 3 4 5 6 7 8. It has also attained the octet. This is the electron dot structure of NH3. So now we are moving on to the next topic, okay, the last topic for the covalent compounds, which is properties of covalent compounds. Now, first property, the constituent particles, the same pattern we are going to follow. How we have studied the properties of ionic compounds, same way we are going to study the properties of covalent compounds, okay. So constituent particles of covalent compounds, we already know, right? They are molecules. HCl, Cl2, H2, N2, O2, what are these? These are molecules, right? Now, next is state of existence. In which state do they exist? So they exist in gaseous state or in liquid state or in solid state, but in solid state they are very soft. Now, why is this so? Why they are existing in gaseous, liquid, or why they are existing as gases, liquids, or soft solids? The reason is very simple. See, since their constituent particles are molecules, right? So suppose I am taking example of HCl. Okay, so HCl, I know this HCl molecule, there would be another HCl molecule, like this way. Okay, now between these molecules, the force of attraction is very weak. Okay, it's not like that of the ions. Ions have strong electrostatic force of attraction between them, but here the force of attraction between the molecules is very weak. So since it is very weak, what would happen? The particles would be farther from each other, right? If here, the particles would be like far away from each other, and we know when the substance is made up of such particles which are farther away from each other, that substance would exist in gases or liquids, right? Because in gases and liquids, the substances are farther from each other. Okay, the particles of the substances are farther from each other. Okay, clear? Now, soft solids. Now, in case if the force of attraction is slightly good enough, okay, so then the particles are closely held, slightly closely held, but then too the forces of attraction are not that strong. So since the forces of attraction are not that strong, though the particles are like closely held and they exist in solid state, but because of the lack of strong force of attraction, we can just break them, right? We can break that covalent compounds, okay, which are in the solid state. So we say that they are soft enough, okay. We can just pull it apart from each other, okay. So they are soft solids. So we are seeing that they are existing in the solid state, but they are soft solids. Next property is boiling points and melting points of the covalent compounds, okay. So covalent compounds have low boiling points and low melting points. Now, why is this so? We have already learned the reason. We know that the covalent compounds exist in the molecules, and these molecules have very weak force of attraction between them, right? Correct. So since they are having weak forces of attraction between them, so if we would give lesser energy, okay, then to what would happen? These forces of attraction would get weakened and the molecules would now move farther from each other, right? And since when they would move farther from each other, we know that suppose in this state, okay, suppose the covalent compound is in liquid state, okay. Now when we gave lesser amount of energy as well, what happened? It readily or it easily weakened the forces of attraction between the molecules. So molecules went far away and they got converted from liquid state to gaseous state, okay. So what does this imply? At lesser energy they are getting converted. When we are giving lesser energy, then too they are getting converted from liquid state to gaseous state. So lesser energy means we are heating at lesser temperature. Lesser temperature means the temperature at which liquid changes into gas is boiling point, right? So substance from liquid state changes to the gaseous state is boiling point, correct? So this means that the boiling points are low because boiling point is a lesser temperature. So here from this we can make out that why the boiling points are low, because of the weak forces of attraction between the molecules. And same case goes with the melting points as well, okay. From solid state to liquid state, okay, when the covalent compound is converted, very less amount of energy is required because these forces of attraction are weak enough. So in order to weaken them, less amount of energy is required. Less amount of energy means we are heating at lesser temperature. Now this temperature, we know the temperature at which the substance changes from solid to liquid is melting point, and yes, this temperature is low enough, so therefore melting points are low. So the reason behind the low boiling and melting point, we have understood it, but let me tell you the keyword which you should not miss while writing your examinations, which is weak force of attraction between the molecules. Just like we had the keyword for the ionic compounds, strong electrostatic force of attraction, right? You don't have to miss this keyword while writing the reason. So this way, in this case, the keyword is weak force of attraction between the molecules, okay, due to which small amount of energy is required to weaken the force of attraction, and this much is enough in order to explain why they are having low boiling and melting points. Now moving ahead to the next property, ionization. Okay, now we have seen dissociation in ionic compounds. Here covalent compounds show ionization. What actually ionization is? It's very simple, formation of ions from molecules. Okay, now polar covalent compounds, okay, they ionize in water. Okay, now why is this happening? What does this mean? Polar covalent compounds ionize in water means, if I'm taking the example here, suppose HCl is a polar covalent compound. So this molecule is getting this, from this molecule ions are being formed. Okay, so which ions are being formed? I'm just writing the equation, don't worry, I'm going to explain you this thing. So these H3O plus and Cl minus ions are formed. Okay, when in water, okay, in water this is happening, the polar covalent compound is ionizing. Okay, ionizing, which I told you, ionization means formation of ions from the molecules. Okay, now why is this happening? Very simple. What happens in water? The fractional charges, okay, of the polar covalent compounds, okay, we already know. See, the HCl is having, fractional means slight positive charge, and chlorine is having slight negative charge. This slight charges, okay, in polar covalent compounds, okay, of polar covalent compounds are converted into complete charges and the ions are formed. Okay, so this slight charges are converted into the complete charges. Here you can see Cl, chlorine's slight negative charge is converted into directly complete negative charge. Okay, here hydrogen's slight positive charge, here H3O plus means, you can also see that H plus is getting formed. Okay, we will understand this thing later, but for now you just remember that H3O plus means H plus is getting formed. So see here, hydrogen's slight positive charge is getting converted into complete positive charge and the ions are formed. Okay, so this is actually happening. That's why the polar covalent compounds are getting ionized in water. Okay, now let's try to understand it in the detail, because we have now studied the structure of water. Okay, so we have a slight idea about the structure of water, and this is the thing which I have told you that I would tell you when you would study the water. Okay, the covalent compound, the covalent bonding and water, because in ionic compounds as well, the water was playing some role in weakening the strong electrostatic force of attraction, right? So what here is happening? Let's try to understand this thing. See, water is having like this structure. Okay, now we know it has slight negative charge. These are two slight negative charges, slight positive charges. Okay, now what is happening? See, the polar covalent compound, which in this case is HCl, right? This is having slight positive charge, this is having slight negative charge. Now this oxygen, okay, of water molecule, when it is coming close to this polar covalent compound, okay, molecule, HCl molecule, it is like having some force of attraction with this hydrogen, okay, with this hydrogen of HCl. Why? Because this hydrogen is slightly positive charge, oxygen is slightly negative charge. So between negative and positive charge, there would be a force of attraction, and this force of attraction, what it does, it weakens the force of attraction between hydrogen and chlorine. Okay, the same thing water was doing in case of ionic compounds. Okay, this slight negative charge, okay, and this positive charge of the sodium, okay, this water was like having a force of attraction with this sodium ion. Okay, and in this case, what it was doing, since see, this oxygen would pull the sodium towards itself, the ionic bond, okay, between Na plus and Cl minus would weaken. You just imagine, okay, you and your friend have held your hands very tightly, but your third friend is now pulling your friend towards himself. Okay, so what would happen? Your bond, okay, your hold, which you are holding your friend, okay, would be lesser and lesser, okay, as your next friend would be pulling your friend, right? So same thing is happening here, and because of this, it is weakening the electrostatic force of attraction in ionic compounds, and same is happening in case of covalent compounds. It is weakening the force of attraction between the covalent compounds as well. Now, since it is weakened, so see this H just plucks out, means gets separated from the chlorine. It gets separated, so its partial, its slight positive charge gets converted into complete positive charge, and see here the chlorine slight negative charge gets converted into complete negative charge. Now, how is this happening? It's also very simple. See this HCl, okay. Now here hydrogen and chlorine have shared a pair of electron with each other. Since oxygen is pulling this hydrogen is leaving the chlorine without any electron. Okay, he is saying that I don't want an electron. I am in affection with oxygen. Bye bye, bye bye chlorine. So it is leaving without any electron. So what would happen? It is leaving its own electron as well. So after leaving its own electron, it would become H plus. And since chlorine here, it is having its own electron, but here it is now getting the hydrogen's electron as well. Okay, so see here 1, 2, 3, 4, 5, 6, 7 electrons, and it is now getting hydrogen's electron as well, and this electron is now also the chlorine's electron. So see, initially it is having 7 electron, it has gained 1 electron. So after gaining electron, it would become Cl minus. So see, H plus and Cl minus, these are getting formed. Okay. Now I think it would be clear in your mind that how water was changing the game, how water is a game changer here. Okay. So now what is happening in case of non-polar covalent compounds? Non-polar covalent compounds do not ionize in the water. Okay. Now let's take an example to understand this thing. So CH4, we know this is a non-polar covalent compound. So here in methane, carbon hydrogen bond, can we see the charge separation here? No. See, they are non-polar covalent bonds. So no charge separation, no slight positive charges, no slight negative charges, nothing at all. So since these molecule, okay, since this compound is not having charge separation, like here you can see in case of HCl, there is a charge separation in this covalent compound. See, here is positive charge, slight positive charge, slight negative charge. So this covalent compound is having charge separation, but this covalent compound is not having charge separation, okay, because they are having non-polar covalent bonds. Now, since they are not having charge separation, the oxygen atom, okay, which is slightly negatively charged, okay, which has slight negative charge, okay, it won't be able to pull any of the atom from this polar covalent compound, right, from this molecule. Now, since it won't be able to pull, so no chance of converting the molecule into ions itself, because it won't be able to break the bonds, okay, break the bonds and convert it into ions. It won't happen. So since because of this lack of charge separation, okay, they do not ionize in water. These molecules do not form ions. Next is conductivity. Okay, so we have to see the conducting nature of covalent compounds, okay, whether they are conducting heat and whether they are conducting electricity or not. So they are absolutely poor conductors of heat. Okay, ionic compounds were good conductors of heat, right? And in case of electricity, they are also poor conductors of electricity. They do not conduct electricity in solid, liquid or gaseous state. Now, why is this so? Why they are not conducting electricity in any of these states, okay, solid, liquid and gaseous state? Because they exist in molecules, right, like this. So there are no ions present, okay, there are no free ions, okay. So if there are no free ions, then how it would conduct electricity? If free ions are present, then they would migrate to the respective electrodes and they would conduct electricity. But if free ions are not present, so they can't conduct the electricity, right? So because of the absence of free ions, they do not conduct electricity. Simple. Now, the exceptional part here is we have already studied just right now that polar covalent compounds ionize, right? The molecules are broken down into ions, or ions are formed from the molecules, right? So right now we have seen HCl plus water. Okay, what is this? The aqueous solution of polar covalent compound HCl, right? It is getting converted into H plus and Cl minus, right? This H plus means H3O plus. Okay, so what is getting formed? Ions are getting formed, and these ions are like must ekdam freely moving into the water, right? So there are free ions now. Now when you would insert the rods and do electrolysis, what would happen? The ions would migrate and electricity will be conducted, right? So aqueous solutions of polar covalent compounds, see here, aqueous solution of polar covalent compound conduct electricity because of the presence of free ions. And moving to the last property of covalent compounds which we are going to study, solubility in water, right? So here non-polar covalent compounds are insoluble in water and polar covalent compounds are soluble in water. Okay, now why is this happening? The logic is very simple, like dissolves like rule. We know polar compounds would dissolve in polar solvents, non-polar compounds would dissolve in non-polar solvents. So same here, water is a polar solvent, right? It is polar in nature. So in this polar solvent, our polar covalent compounds dissolve. Okay, non-polar covalent compounds won't dissolve. Okay, now let's try to make it simpler. We have already learned this thing. You just try to relate this thing. See, non-polar let's first see polar covalent compounds. We know HCl. Okay, there is charge separation, slight positive, slight negative. What water does? Okay, its oxygen atom just pulls off this hydrogen, okay, from this HCl. It ionizes, okay, this HCl molecule, and what is formed? H plus and Cl minus is formed, and when these ions are formed, we say that our HCl is solubilized, means our HCl has been dissolved in water, right? But whether in case of methane, okay, would it be the same case? Here there is no charge separation, so here oxygen is not able to pull out any atom, so here the molecule is not getting ionized in ions. Since it is not getting ionized in ions, we say that, oh, our covalent compound is not dissolved, okay, in water. Very simple. So see, non-polar covalent compounds do not dissolve in water, since they are, so we are calling them as insoluble in water. Polar covalent compounds are dissolving in water, okay, so polar covalent compounds are soluble in water. Now moving to the last topic of this video. So there is a point that you have to study the comparison of ionic and covalent compounds, okay, in your syllabus. So what we have actually done is, in ionic bonding video, I have explained you all the properties of ionic compounds. Now in this video, I have explained you all the properties of covalent compounds. Now what is the comparison? What we have to do in comparison? You have to just write the properties in front of them, okay. In the ionic compound particular property you have to write, and then the covalent compounds particular property you have to write, then automatically they are getting compared, right? See, the ionic compounds first property we have learned, constituent particles are ions, covalent compounds constituent particles are molecules. We had done the comparison, okay, first comparison. Then ionic compound exist in solid state, right? Hard, they are hard solids. Covalent compounds exist in gases, liquids and solid state, but these solids are soft, just now we studied. Then ionic compounds have high boiling and melting points, covalent compounds have low boiling and melting points, okay. All these things we have studied along with the reason as well, okay. Same way, ionic compounds, in ionic compounds the ions dissociate in molten and aqueous state, okay. And in covalent compounds, polar covalent compounds ionize in water, correct. Next is conductivity. We know ionic compounds are good conductors of heat, covalent compounds are poor conductors of heat. Then ionic compounds are good conductors of electricity in aqueous and molten state, but poor conductors of electricity in solid state, right? And in the same way, like our covalent compounds are also poor conductors of electricity, okay, in solid, liquid and gaseous state. But the exception we have studied, in the aqueous solutions of polar covalent compounds, okay, the aqueous solutions of polar covalent compounds conduct electricity, right? Just now we have studied this thing, correct. And then lastly, the solubility wala point, ionic compounds are soluble in water. In case of covalent compounds, polar covalent compounds are soluble in water, non-polar covalent compounds are insoluble in water, okay. So yes, here we have compared the properties of ionic compound as well as covalent compounds. Now let's see some questions to test whether you have understood the concepts which we have learned so far or not, okay. So first is, choose the correct answer from the options given below. A compound with low boiling point is, okay. sodium chloride, calcium chloride, potassium chloride, carbon tetrachloride. Okay, so this was asked in your examinations 2020. And now out of this four, which do you think? Okay, you have to pause the video when I read the question, try on your own to answer that question, and then you again resume it, because I'm going to tell the answer very quickly. Okay, so sodium chloride, calcium chloride, potassium chloride, and carbon tetrachloride. See in this, NaCl, sodium chloride, calcium chloride, CaCl2, potassium chloride, KCl, all these are ionic compounds, and we know ionic compounds have high melting and boiling points, right? Now here we are concerned with boiling points. So see, the compound with low boiling point, but these three are having high boiling points. Now see, the last one is carbon tetrachloride, CCl4. This is a covalent compound, and just now we have studied covalent compounds are having low melting and low boiling points. So low boiling point compound is carbon tetrachloride, right? This is exactly matching. D. Okay, give one word or a phrase for the following statements. The chemical bond formed by a shared pair of electrons. Okay, there is a shared pair of electron, each bonding atom contributing one electron to the pair. Each bonding atom, suppose A and B are the atoms, each bonding atom is contributing one electron to the pair. Now, which give one word or a phrase for the following statement. So what do you think? You have to write the name of the chemical bond here. Okay, so which bond is formed by the shared pair of electrons? And in the shared pair of electron, each bonding atom is contributing one electron to the pair. This means mutual sharing of electrons. We know this is covalent bond, right? So answer is covalent bond. Okay, moving ahead, fill in the blanks from the choices given in the brackets. The polar covalent compound, okay, in gaseous state that does not conduct electricity is dash. Okay, out of these three we have to choose. Okay, so let me tell you one thing, I'm not going to explain the answers of all the questions. Those questions which we can answer easily throughout by watching the video, okay, by learning all the concepts which we have already studied, okay, before solving the questions, I'm not going to explain them in detail. Okay, but don't worry, those questions which need some explanation because they are quite difficult or like something like that, so I would explain it. So first two questions were like very easy sort of questions. If you would have studied, if you would have paid attention and you would have understood the concepts, then you would easily answer those questions. Okay, but this question, see, this is like quite tricky. See, the polar covalent compound, first we have to find which is the polar covalent compound among these three, and there we get the answer itself. Okay, so see, carbon tetrachloride, methane and ammonia. So CCl4 and methane, we know they are non-polar covalent compounds, right? Only our bichara ammonia here is polar covalent compound. So answer would be ammonia, right? But don't be in a hurry. Let's try to match all the other things as well, okay, whether they are satisfied or not. Okay, so in gaseous state, yes, ammonia is a gas, we know, that does not conduct electricity. Yes, now since it is a covalent compound, we know covalent compounds in solid, liquid and gaseous state do not conduct electricity. So yes, all the three things are matching. So our answer is ammonia. Okay, now give the appropriate term defined by the statement given below. We have to just give a term. The covalent bond in which, so they have given us a covalent bond, right, in which electrons are shared equally between the combining atoms. We have already studied this thing. Such covalent bonds in which electrons are shared equally are called as non-polar covalent bonds, right? Non-polar covalent bonds. So this was asked in your examinations in 2019. Previous one was asked in your examinations in 2020. Now moving ahead, draw the electron dot diagram for the compounds given below. Represent the electrons by dot and cross in the diagram. Atomic numbers of oxygen, chlorine and hydrogen are given to us. Okay, so they are asking us to draw the electron dot diagrams for chlorine molecule, water molecule. So see, they have asked this question to draw the electron dot structure of chlorine molecule in 2020. Water molecule is also asked in 2020 in your examinations. We already know, we have already studied how to draw the electron dot structure of chlorine molecule, water molecule as well, right? Now, draw the electron dot structure of nitrogen molecule. This also we have studied. This was also asked in your examinations 2019. See, they have given us the atomic number of nitrogen as well. Okay, so what you can do is you can just pause here. You can just try to draw the electron dot structures, and you can check whether you have drawn right or wrong by moving back in the video, because I have already taught you how to draw the electron dot structures of these molecules. Okay, and the last one is draw an electron dot diagram to show the formation of methane. This also we have already studied. So its atomic numbers are given, and this was asked in a 2017 examinations. So you can clearly see, after studying the concepts, okay, you can almost easily answer the questions which have been asked in your examinations, right? So, and one more pattern, you can see the electron dot diagrams questions, they are being frequently asked. So that's why I was telling you that this topic is quite important. Okay, you should be thorough with it. How you would be thorough? You should know the process, how the particular molecule or compound is getting formed. Then you would exactly correctly draw the correct electron dot structure. Now, moving to the next questions. 8. Give one word or a phrase for the following statement. Okay, process of formation of ions from molecules which are not in ionic state. Okay, so just now we have studied the formation of ions from molecules, okay, is called as ionization, right? And they have also given us a hint. These molecules are not in the ionic state. Yes, right, the molecules are not in the ionic state. So yes, our answer is right. This process is called as ionization. Okay, now this was asked in your exam 2018. Okay, next, choose the correct answer for the from the options given below. Okay, which of the following is a common characteristic of covalent compound? Common characteristic. Okay, so first one is high melting point. Absolutely not. Covalent compounds have low melting point. Now, by the time you would have memorized it as well. Okay, the next is consists of molecules. Yes, covalent compounds consist of molecules, right? But we have got our answer, but let's check the rest too as well. Okay, let's see what they are saying. Always soluble in water. No, right? Because polar covalent compounds are soluble, but non-polar covalent compounds are not soluble in water, right? We have studied this thing. And conducts electricity when it is in the molten state. Absolutely not. They don't conduct. Molten means liquid state, right? So we know that covalent compounds don't conduct electricity in solid, liquid and gaseous state. Okay, they only conduct electricity when they conduct electricity when the polar covalent compounds are added in water. Okay, the aqueous solution of polar covalent compounds, they only conduct electricity. Okay, so our right answer is consists of molecules. Okay, then last one, the state the type of bonding in following molecule. Water. So see, such simple questions have been also asked. We have studied all the Rama and Mahabharata of water as well, right? So we know the bonding which is present in water is covalent bonding, right? So friends, with this we have reached the end of this video and we have learned all the concepts of covalent bonding in this video, right? So I hope you would have enjoyed learning with me, you would have understood all the concepts, but please do let me know in the comment section whether you have enjoyed or whether you have understood the concepts or not. And you all know, LearnoHub matlab free hai par best hai. So stay tuned and we will see the remaining concepts of this chapter in the next video. Till then, bye bye and have a great day.